All right, for this one, well, we want to factor out anything that we can. And again, I'm expecting this trinomial to factor out into x plus 2 times x minus 4, but let's just double check, okay? So, let's give ourselves some space here. Let's take that, put it over here so we can start working with it. But now that I got it separated, I know I got a coefficient of x that's a phantom 1, so I'm going to take the negative 8, find two factors of negative 8 that add up to negative 2, and that would have to be negative 4 and positive 2. So again, negative 4 times 2 is negative 8, but negative 4 plus 2 is negative 2. That's the whole point. And then we take this shortcut. I've got factor of negative 4 and positive 2. So it did exactly what I thought it would. This factors into x minus 4 times x plus 2. Now, that's pretty good. Okay, so we can take this whole equation, let's rewrite it. Okay, but now, instead of having that x squared minus 2x minus 8, let's go and cover that up. Okay, and we have what we found, which was that it factored into x minus 4 times x plus 2. So that's pretty good, right? But before we proceed, you'll want to notice, well, I look at this and I think, well, I can factor here. Actually, I don't think that's going to help us, okay? So I'm going to actually proceed, even though this can be factored and you may want to factor, I'm not going to do that yet, okay? So what I'm going to do is I'm going to force all of the denominators to be the same, right? So for example, this denominator has x minus 4 and x plus 2. This one right here has x plus 2, but it's missing an x minus 4. Okay, so I gotta apply it both to the denominator and numerator. Okay, now again, once we get those denominators to be the same, we can ignore them. But even over here on the right, I've got the x minus 4, but it's missing an x plus 2, rather. So I've got to multiply the numerator also by x plus 2. Now, having done no more work here, I have matching denominators, and they're even the same order. That's convenient here. But the denominators are all the same. That means I can rewrite this without any denominators. All right, so I kind of use some technology to help me, but hopefully we can see the importance of not factoring out a 2 from this part of the expression. Now, the way I have it, I've purposely written this incorrectly because what you're going to want here is parentheses around the 2x minus 38 because it was subtraction. Remember, with subtraction of these expressions, it's kind of like we're going to have to distribute a negative 1 there. Now first, though, I do have this x that I must distribute. So I've got x times x, which is x squared, x times negative 4, which would be negative 4x's. And now I'll distribute the negative 1 times first the 2x, which is negative 2x. And then negative 1 times negative 38 is positive 38. Then on the right side of the equal sign, okay, we got to distribute this 5. 5 times x is 5x. And then 5 times positive 2 would be positive 10. So these two equations are equal. It would be nice to make it equal 0. But even before that, I mean, whether you do it now or later, I'm going to go ahead and combine these like terms. I got the x's right there. Negative 4x's minus 2x's is negative 6x's. Everything else stays the same here. So this is what I got. You can condense it over here if you want, but I'm going to keep it here. Now that I have that, I go to a principle of equality. And it looks like I got to get rid of those 5x's, right? So I'm going to subtract 5x's rather. Now, where do we put the minus 5x over here? It's an x term, so you got to keep it with the x's. And we see that will be important in 5.6, okay? So I'm subtracting my 5x's there. That zeroes those out as planned, but the 10 as well. I want to zero that out as well, so subtract 10 from both sides. So what am I left with? Well, the x squared gets the drop. Negative 6x's minus 5x's would be negative 11x's. And then 38 minus 10 is going to be negative 28. Okay, but now this all equals a 0. Okay, because the 10's also that zeroed out too. Now from here, we're just looking to factor out the negative 28. And there, we're looking for two factors of negative 28 that add up to negative 11. So that appears to be, I was thinking 7 and 4, but only one of them can be negative. so that's not going to do. Okay. What about, so 1 and 28 don't work. 2 and 14 is close, but it doesn't work. So not divisible by 3, but 4 and 7, it seems like it should work. Oh, here we go. I found it. 38 minus 10 is positive 28. So that now will work. Again, these multiplied together and then added is going to be positive, but I can make both those negative, okay? So that's good news. A little bit of a mistake, but it's still good news that we can't do it. So the leading coefficient is 1, so I got x and then a negative 4 and then also a negative 7. Again, if this would equal 0, then it means that in solving for both the solutions, I would solve them both. So I'd say if that x minus 4, if I could make it equal 0, then I'd get a true statement. So I would add 4 to both sides, and I would find that x could equal 4. And then on the other hand, I got x minus 7. If I could get that to equal 0, it'd be true. So I'd add 7 to both sides, and I'd get x equals 7. Now, are these true, though? Remember, the thing we need to remember on these is that you need to check from the original equation, right? So I'm going to take this original. I'm going to start with x equals 4. So I'm going to take all the x's and replace them with 4. So it's positive, so I don't really need parentheses around these. So you have this one being multiplied. Okay, and then I am checking for truthfulness here. Now, before I proceed, the one thing that I noticed right at the end is that this is going to be 0. 4 minus 4 is 0. That can't happen. It's undefined. So it looks like 4 is not actually going to be one of the solutions there. All right. So that was just checking the 4. On the left side, you may have gotten an answer. It doesn't really matter. In fact, I don't think you will, because that'd be 16 minus 8 minus 8. That's going to be 0 on this denominator as well. So next, I've got to go in, and I've got to replace the x's now with 7s. Right, so there's 7 here. Again, I'm putting those 7 in parentheses because they're being multiplied. Even the 7 to the power of 2, I don't really mind. If it's negative, then I would need parentheses there. But let's see what we'll get. Okay, so I don't see any problems with having a 7 in the denominator. If it was a negative 2, that would be a problem on this one, or even this one. Let's see what we get. 7 n over d, 7 plus 2 minus, again, n over d, 2 times 7 minus 38, all over 7 squared minus 2 times 7 minus 8. Enter. All right, well, I got something here. So again, is this true? On the left, I got 5/3. On the left, on the right side, rather, I can see 7 minus 4 is going to be 3. So yeah, that's true. All right, well, that's nice because that means we did actually find one solution. Was the other one true? It wasn't. But it didn't matter. So this one, again, the 4 didn't work because one of the denominators was 0. And that's okay if that happens. What you don't want to see is that you just have an untrue statement here. If that happens, then usually that means somewhere in this problem you've made a mistake, which can happen as well. So yeah, one of the students, they did this. Somewhere in here they made some mistakes, and so they just found that one of the values was false. They did find this one was true, so somewhere there was a mistake that allowed this 7 to happen, but right here I think they got a negative 4, again, which would just produce an untrue statement. But the 0 denominator, when it's positive 4, that's where it may have been a similar mistake like right here, right? Remember how he wrote negative 28? Because I just didn't I didn't have it as positive 28, okay? So expect yourself to make some mistakes. Be lenient with yourself, but always double check your work, just like I did, right? Like nothing was working here with my 4 and 7 when I was a negative 28. Okay, I went back and I checked. Yeah, I made a mistake there. Expect to make mistakes, expect to learn from them, and move forward. Okay, we can learn from those.